Okay, in this lesson, we will see how to use super mesh condition where here we have a super mesh and super node. So super mesh exists when you have a current source in between two loops. In two loops, you have a current source, whether it's actually current source alone or with a resistor. In the situation actually same. Okay, so like what we usually do, we will write the equation, right? So let's say we write the equation as ix here because already ix given, and iy, let's say we call this equation iy, and this direction should like this. And we won't take two loops like this, we will make it as a single loop, as this is actually super mesh. Okay, and then one more equation we will obtain from this current source here, where this is actually the difference between the iy and ix. So for this loop 1, equation 1, where we have formed from this both loops as a single loop, so 9 volt minus, just for our reference, write this, minus 2k iy minus 3k ix equals to 0. So rearranging this equation, we can have 2k iy, so iy, sorry, this is not 3k, this is 0, so 2k, typo here, 2k iy plus ix equals to 9 divided by 2k, you will have 4.5 milli here. Okay, and for the second equation, this is actually the i1. See, i1 equals to the difference between ix iy, so ix minus iy. What is i1? 0.01. Okay, so negative iy plus ix with the second equation. Okay, so by solving these two equation, we will get iy as negative 2.75 milliampere, which means in actual the current flow on this direction. Okay, after this node, and ix equals to 7.25 milliampere. So this is actually same direction with the direction we choose, so the current flow in this direction. And that's how we will solve when the circuit have current source in between two loops. So we call it as a super mesh. Also, we also call it a superposition technique, and this is one of it, super mesh. And for the second case, this is actually where we have a voltage source in between two nodes. Okay, and this is considered as a single node, super node. Okay, then we also observe how many nodes, effective nodes, this circuit have. So this is only have here one node and another node. This node voltage already known, so P1 already known, 9 volt. And let's say we call this as VA and this is as VB. Okay, so we write the equation, okay, for the current flow through this here. So let's say we call it as this direction like this, So these two current actually go inside these two nodes, I mean the effective node Ix, and so I call it as I1, I2, and this is as I3, and this is Ix. So I1, and when we write the equation, I1 plus Ix going inside the node equals to I2 plus I3 coming out the node. So the equation for I1 is equals to V1 minus VA. V1 we can directly write as 9, since already given, over 2k plus this is V1 minus VB over 4k equals to VA over 3k plus VB over 2k. And then this k can be eliminated since having both side of the equation, and we multiply with common multiple number, which is the common multiplication for this is 12. So then we have 54 6VA plus 3V1, sorry, V1 can be written as a 9, V1 equals to 9, right? This is 9, so can directly multiply it. 3 times 9 is actually 27 minus V 3VB equals to 4VA plus 6VB. Okay, then rearranging this equation, we will have 81 54 plus 27 81. Here VA we have 10 VA, and VB we have 9. So this is one of the equation. A second equation from this node, the voltage difference between node A and node B, VA minus VB is actually 3. So here we can use a simultaneous equation to find the VA and VB. So VA we will get as 5.68 volt and VB as 2.68 volt. Then if you want to find the Ix here, so that's actually refer to this expression where we can find as 9 volt minus 2.68 Ix over 4k. We have 1.58 milliampere. Okay, so that's how we will utilize the supernode to solve the circuit.